Welcome back, folks, to another episode of Speech Processing. Let's take a look at some more TTS applications, more on speech processing. Let's do a little bit of history real quick. The first engine, so to speak, was the acoustic mechanical speech machine built by a German, Wolfgang von Kelpen. I'm not sure how to pronounce that, sorry. In 1791. That's not a typo, 1791. And here's a Wikipedia article on his little device where he had a bellow that would blow the arrows like the source, and then he would filter it with the certain little device he held, and he could move it around and change the configuration of the little leather pouch that the air went through. Anyway, that's kind of like the first TTS, you might say. And here's a replica that was built in 2007 through 9 in university in Germany, Department of Phonetics there, if you want to take a look at that. The first talking chessboard in 1979.
I am Fidelity's chess challenger, your computer opponent.
Yeah, pretty darn robotic, right, for 1979. And just to review, there are three kind of basic techniques. One is acoustic synthesis, one is concatenative synthesis, and one is articulatory synthesis. And there are two or three paradigms of processing. One is a rule-based with like a hidden Markov model we've seen in the past. Others are machine learning classifiers, and neural systems neural network. Deep learning is a type of machine learning. And so far, most studied it as a standalone process. But how else can a TTS be used? A TTS system be used? Now let's talk about evaluation real quick. Competitive evaluations. This Blizzard competition has been running, hosted by Carnegie Mellon University for the last couple decades on TTS systems. And they give a data set, like they give data to a team, or a bunch of different teams, and the team does whatever they want to create a TTS system, and then human judges judge or rate the quality of the TTS output. Okay, and so here's some different teams from a recent one from CMU, Carnegie Mellon University there. This is from the University of Edinburgh, this one, or the Center for Speech Technology Research there, and other universities, Germany and Japan and China. So here is a somewhat recent Scientific American video about TTS systems from a couple years ago now. And you can take a look at that if you like there. Okay, there are some clinical applications of TTS systems for the blind. I have some links here. Screen readers, right? Obviously, it's an important part. Stephen Hawking's assistive device. I assume you've heard of Stephen Hawking's. He had a TTS system that was based on eSpeak, and that's why it sounded pretty robotic. In fact, this link here, on this sub-bullet, you can actually write in, let's see, I'll say, I love teaching linguistics, and listen to...
I love teaching linguistics.
Right, it's using eSpeak under the hood, and that's why. Anyway, back then it sounded pretty robotic. Still does. Here's a Wired article about his voice there from 2015. Anyway, there's also can be research into speech production and articulation, and doing imaging of the vocal folds and the neuromuscular control of the tongue and the velum and things happening. And I've shown actually some X-ray videos of the vocal apparatus in previous lectures. I'll let you look at those videos if you like. Here's a system that is no longer maintained, produced at the Center for Speech, Language, and Understanding in Oregon. They had this on the top right of this screen. You can see this picture, screenshot of some software from the past that's no longer maintained, that you could put facial gestures and eye gestures and emotion and even different skin tones into this talking head thing, and create a kind of a flow, control flow through the system there. Here's a somewhat similar thing these days at Bulwark Learning. Let me see real quick if this is worth our time. I watched it earlier. Anyway, I'll let you look at it. It's kind of a similar system
Kayla,
where
was 17. What Kayla liked the very best of all, though.
anyway, so there's research into trying to make talking heads, and then I showed an example in the previous lecture of that advertisement for a PhD program at a university in Sweden. So there's a lot of advances going on here. Singing voice synthesis is an interesting field. There are two pipelines, the usual TTS for a voice in blue at the bottom part of my screen. Let me remove myself for a second. The bottom part of my screen, the bottom right, we have the typical TTS where we have a text go in, do all the stuff that needs to happen to get speech. And then we have another pipeline that is the score, like information about the musical notes, the pitch, and the duration of each of those notes goes in, and those come together to create a singing voice, right? So it's very easy to do in Festival. In fact, for the lab, you're going to do this. We'll do do re mi. This is a do re mi. You can see how this is organized. Let me zoom in a bit more here. You can see the pitch. The note is G3. The duration is 0.3 beats. You're going to say do. Then you're going to go up a note to re, then go up another note to B, 3 to mi, etc. Just going up, right, the do re mi scale. So that's some XML notation right there, where you can put in pitch and duration and give the note there on the pitch as an attribute to that XML tag. Okay, here's some examples of singing.
Daisy, Daisy, give me your answer too. I'm half crazy.
Anyway, so it's pretty robotic, right? Here's another one.
Oh, beautiful for spacious skies, for amber waves of gray.
And here is one you may recognize.
Rise and shout, the cougars are out along the trail to fame and glory.
It was using Festival, which, the voice is pretty robotic, right? Some past systems. Here's some past systems, and this website has some alternatives to the Flinger system, Vocaloid, and some other systems there that are singing TTS systems. OpenAI has a jukebox system called Jukebox. It's a musical neural network that generates music, including rudimentary singing. And here is a video I have of somebody using this system to create some music as well as singing. So take a look at that video. I just started it and stopped. Here's an interesting video about this, actually LDS, speech pathologist, I think he was, or a phonetician, created a singing TTS system back in 1992, and this is a video of it.
I would like to introduce to you tonight my guest performer. His name is Pavarotti. Yes, to make it easier.
He's got a picture of Pavarotti, but he's doing speech synthesis there back in 92. Check out that sweet monitor from 92. And he actually gave a devotional at BYU Forum. It wasn't devotional, it was a BYU Forum where he demonstrated that system here at BYU. You can listen to the speech here from him from 98. This is from 98 there. Vocaloid, virtual vocal software there, Deep Singer, neural approach. They have some good examples. Check this out. This is in Chinese. Listen. Anyway, so yeah, there's research into singing TTS. And the lab for the lab this week, I'll have you use the festival, just using some notebooks to go through, using a notebook to go through the festival TTS system. Okay, good. Do-it-yourself animation scripting. I'm sure you've seen these type of movies from Extra Normal. These type of talking figures. Maybe you haven't. Here's an example for you.
Hello, boys and girls.
Welcome to the word of the day.
Today's word is despair.
TTS.
Anyway, so in addition to the TTS, which is happening, you can tell it's a TTS voice. The animation is also happening with automatedly. There are educational business apps for that type of thing, animation scripting. Silent speech is really interesting. Another technology around TTS. Here's a great article on Wikipedia about it. Silent speech interface is a device that allows speech communication without using the sound made when people vocalize their speech sounds. As such, is a type of electronic lip reading. It works by the computer identifying the phonemes that an individual pronounces from non-auditory sources of information about their speech movements. These are then used to recreate the speech using speech synthesis. So not actually speaking, but it's monitoring things happening on your face and your jaw and your throat, and then it produces the sounds that you are seemingly making with those movements, but not actually making with your actual voice. So on the top right of the screen, we see some nodes, some sensors on this man's face, on his throat down there. So this can have some applications for like clinical people. If somebody had their vocal box removed because of cancer or something, or had some problem with their voice, they could perhaps still have a voice, synthetic voice with this technology. There could be military applications if people can't speak out loud in a certain situation but need to communicate. Here's a newer system that uses a camera. Pretty interesting. These students at Cornell University created a system that uses a camera.
Imagine when your hands are occupied, or you simply don't want to reach out to your smart devices to interact with them. You might want to use voice control. However, in a quiet place or in a noisy place or in a meeting, voice control is sometimes not efficient or not socially appropriate. This is where silent speech came into place. SpeechN is a smart necklace for silent speech recognition.
Anyway, you can take a look at the rest of the video if you like. And it was pretty interesting that this camera is just monitoring his jaw and throat, just looking at it, and based on machine learning, it's saying, oh, it sounds like it looks like he's trying to say switch to Taylor Swift, even though he's not actually voicing it. You can hear him slightly whisper in the video. Okay, so that's silent speech technology. So the next slide, this is a pretty short video here. Next slide is to work with the third TTS engine of your choice using the slides that, I'll show you in a second here. And then if you read music, well, even if you don't, I want you to click through my notebook there. And then to work with Nemo from NVIDIA in Colab to punctuate an ASR transcript with NLP techniques, and then note the difference in the effect of punctuation on the TTS. Let me jump over to the lab here. Right, and so you can grab any third system that you would like that you haven't previously looked at. Again, I have some examples on slide 14, what is now numbered slide 14. Example systems here. Any of these you'd like to grab, and or just go out to Hugging Face. And right now I'm looking at text-to-speech models. Try one of these, make one of them work, or compare them. Pretty simple to use, right? Pretty easy to get going. So do that, and then learn how to create a singing TTS voice with this Google Colab notebook I have there. Again, you'll download it to your hard drive and then upload it to your Google Colab space. And then if you actually read music, you should try and synthesize a song or do something to create something new. there if you know how to read music. And okay, and then here's this excuse me, this collab book using Nemo from NVIDIA to perform ASR, and then to use natural language processing techniques to repunctuate the transcript, and then use TTS to resynthesize the audio with another voice using WaveGlow. And the point is to see how the TTS is better when it's punctuated, and how it's different and better when it's punctuated. So, okay, so that's the lab. Next, the second lab for TTS. All right, well, that is a quick little video about some applications of TTS. See you next time.